There are many things that kids these days will never experience, like physically hanging up a phone or waiting for a VHS to rewind. You can probably add changing headlight bulbs to the list, and thank goodness because mine are virtually impossible to get out anyway. Akos Labadie from Eaton Electronics is here to talk about how and why automotive manufacturers are doing away with all of those bulbs in favor of LEDs, and how to effectively and efficiently manage their power. Welcome to Tech Chats, Akos.
Hey, Chris.
So let's talk about LEDs and how they're being used in vehicles.
All right, so it's probably not surprising. So everyone who is traveling on the roads probably noticed that most of the traditional halogen bulbs are kind of disappearing right now, and everyone is all the OEMs, all the car manufacturers are turning the lighting systems into cooler and cooler LED types. Basically, what we called like the first matrix LED lights had the functions to actually illuminate simultaneously the different parts of the road and the side. So those were pretty cool LED lights. So you probably have heard about laser lights that can illuminate very sharply for a very high speed driving. And there are more to come with more pixel LEDs that will be basically continuously shaping the light paths according to the occurring traffic. So modern LED lights, especially the headlight units, are really going into the direction to illuminate more, so give more visibility to the driver, and less distraction for the others on the road, and provide a safe and cool look. And this has been already becoming a signature of car makers, so you can see them approaching and can recognize the vehicles more from the front lights than from the emblem of the cars. So what's going on with the taillights? So you have probably seen some animated taillights already on the road, and actually in terms of the taillights, the options or the potential is even larger. And by shaping the taillights actually in a pixel-like shape or with a special optics, you can actually use these lights for a lot of safety features. You can communicate through these lights. Some brake lights are actually start to blink when you are really decelerating fast and then jumping on the brakes. With pixel-based tail lights, you can actually send much more in addition. The driver may see how far your vehicle is charged, for example, just clicking a button on your remote, or it may actually draw you the path where your vehicle is approaching when you're backing up. So there are many options for this, which is already technically available, but there is more of a restriction from the authorities to allow car makers to implement this kind of features.
What about powering these LED lights? The voltage supply in a car can be all over the place.
All right, that's a really good question, and that lays actually behind why these lighting fixtures are so expensive. So one point is that is special about automotive LED lighting, if you want to have a long-lasting solution, is that you need to manage somehow the continuously fluctuating input voltage. Now, this voltage is fluctuating actually according to the alternator speed, which is your RPM. So this may lay somewhere between 8 volt and 18 volt for if you talk about a 12 volt battery. LEDs require really stable driver output voltage and current supply without any major ripple outputs. So you need something, an LED driver, which need to supply continuously stable required voltage output, current output, current capability, and also fluctuating power level to be managed from the end. And in addition, there are also the wide operating temperature range that is required. In case of automotive, you have basically a fluctuating temperature between minus 40 to plus 125 Celsius degree.
So, how do designers make gate drivers that handle the input and output issues, plus the others that you've got listed here?
Yeah, so normally, if we talk about a low-cost headlight unit, there is a very smart way to manage the fluctuating input voltage of a battery to a stable voltage and the current output with a SEPIC converter. SEPIC is a very smart design that is a buck boost topology. So independent from the input voltage, whether it's above the output voltage or whether is below the output voltage, this converter naturally adjusts itself, and that's very smart. And there are also some smart ways to reduce the footprint and the component size, by, for example, having a coupled inductor, which we are quite strong and actually had developed for LED lighting, and this converter can actually do most of the job. So there might be one or two additional buck converters, very simple ones. If the voltage range is really low, for example, for an indicator light, there might be a specific buck converter needed, but most of the power LED, the illuminating LED functions can be managed by a single SEPI converter. While the other one, I already see it in the mid class, is a specific topology which consists of two different topologies managed by normally a microcontroller. So what we have here, we have an input battery voltage, and then the manufacturers are making installing a boost converter first that makes actually a manageable boost voltage level between normally 22 to 60 volt DC. And taking this, let's say, regulated boost voltage, there are many channels of buck converters connected to it. So we call it them channels, which is associated with one LED string or one larger diode. And it may be providing 3 volt all the way up to 24 or even up to 36 volt to each of the channels.
And what does that mean for the inductors that you make?
So we see that LED lighting is really remains at this 250 450 kilohertz range, and interviewing the customers, they don't have any plans to change that. But what they requested us is always to make it smaller and smaller. So size starts to become an issue, and the weight starts to become an issue, and also the efficiency. And we are purposely trying to find new solutions and a new type of core materials, or fine-tune them based on the existing technologies according to the specific requirements for the LED drivers.
Let's talk a bit more about those materials and how they change the inductor's performance.
So we try to find materials that tends to allow less and less saturation and more predictable saturation. So ferrite materials, they tend to have a very stable roll-off characteristics, so they are outputting quite high, or they are having an effective inductance at a quite stable level all the way up to the a saturation point where it really stops it up quite sharp. And this is also temperature dependent. So at low temperature, ferrite inductors perform much better. At high temperature, they saturate much quicker. While the powder inductors, which is otherwise called the molded inductors, we call it soft roll-off characteristic inductors, and they are much more favored in like an LED design that may work at a very wide temperature range, and the current level may fluctuate a lot. And one aspect which we didn't touch yet is electromagnetic capability. So ferrite inductors are normally called shielded ferrite inductors. They are not really that much shielded, so they are still generating a lot of noises. And in opposite, the molded inductors output basically outside of the inductor package hardly any noise is coming, hardly any magnetic fluxes are coming. So in terms of EMI, they can be managed much better as well.
It seems like molded inductors are maybe the preferred solution. Can you talk a bit more about those?
Yeah, so we're actually at kind of like the third generation of materials which we have in production right now. So we started with sintered molded inductors. So they were not really molded inductors, but they were sintered material, powdered material, which we assembled. And they are still used in automotive electronics a lot. But being an assembled device, they are quite labor intensive. So we are trying to find ways in order to manufacture more efficiently. That's when the molded technology came into the picture. So the molded technology is quite simple, quite straightforward, that you actually use a pre-wound core, and you put it in a mold, in a metal mold, and you fill it with core material through pipes into a multi-cavity tool, and we make a press and cure it, and the inductor is done. So it pretty much can be automatized in terms of the manufacturing and significantly reduce the cost. So HC, high current, was the very first family. Then came the HCMA, which is high current molded automotive. And the need of having a high temperature inductor lead us to develop the HCM1A, that is high current molded grade 1 automotive. And in our roadmap, we have even an expansion and going toward automotive grade 0. And we are also working on some hybrid materials to get higher inductance values. With the hybrid technology, we hope to get it achieved in size compressed format.
So, what's a hybrid inductor?
So, in terms of our roadmap, as you could see that we are working on this next generation molded or hybrid inductors. And we talked earlier about ferrites and molded inductors and the differences. And yeah, ferrite has actually some advantages as well that we can build in a higher inductance values, which are desired for like the turning indicators of the LED lights, and also for the tail lights. That's very important to get to all the way up to 330 microhenries, and that's impossible with the current molded technology. So new hybrid material, what it does is that it's having an extremely high saturation current capability. So this allows us to use much less number of turns of wire. That helps with two things. We can save more core material in terms of to set the saturation, and on the other side, it actually it's decreasing the overall DCR of the device. That is mainly accounts for the self-temperature rise and the efficiency losses of the inductor. So these new inductors allows us to build high inductance values in a much smaller size as a ferrite solution currently used would be. Probably half of it, at least in terms of the footprint, and at the same time can provide a much higher efficiency, or it can actually help to boost some of the power of the LED channels if it's required. So overall, and in a package that has the same molded type of low EMI feature.
With these different inductors or core materials, what are the benefits designers will see?
All right, so currently the biggest challenge is how to make LED drivers as small as possible and as high efficiency as possible at a reasonable cost. So all our development is in terms of providing components like magnetic components, inductors for the automotive LED lighting market, is to try to reduce the footprint as much as possible, increase the inductance values as much as possible, while decreasing the DCR as much as possible. But in order to do that, we have to find new materials with higher permeabilities in order to keep the required level of saturation current. And this all adds up in the overall efficiency. So automotive lighting designers started to recognize that different manufacturers, similar looking inductors, actually perform quite differently.
And what goes into developing and optimizing these different inductors?
So we have actually, when we develop an inductor for a specific application, we actually, if we know what really our customers are expecting, like in terms of efficiency, and we know the parameters of the whole converter, we actually can fine-tune the ratio of the total losses divided into DC losses and AC losses. So actually we can fine-tune an inductor to have a specific level of DC losses and AC losses, which is actually we have advanced simulation capabilities that allows us to set the inductor with differently configured raw material mixes and winding structures to see what the output may become. And since we have very good information from our customers, we actually can deliver them the the best inductors that fulfilling um, the requirements of the space or footprint, as well as the total efficiency. So what we try to achieve here is actually contribute to the emission norms, as lighting fixtures tend to be still a bit lossier than in an industrial or in the consumer market. And by delivering the best efficiency inductor components, which actually accounts for most of the losses in these converters. And overall, we try to reduce the weight, which helps with the vehicle weight, and try to minimize the losses, which contributes to temperature rise that is actually shorten the lifetime, especially for the surrounding components on the PC board. And the overall efficiency is also helping to reduce um, the, the, the emission of the vehicle at the end. So that's where we put a lot of efforts in terms of the development to actually address these challenges and deliver in a form of inductor that is mostly appreciated by our customers. And just as a summary, so it's not only front lights and the tail lights. You have all kinds of ambient lights and actually some just cool like bay lights or some special illumination to help the driver to find their cars. So that's why we are here with Eaton and try to help with our standard product lines, as all the driver topologies and the concepts are getting more and more standardized. We also try to fine-tune our standard product lines, which is high current molded inductors like our HCM lines, or the drum core automotive like the DRA or DRAQ, and or we have miniature power inductors mainly for the ambient and the internal lights, which is the or MPI lines or MPI-A lines that is addressing the different type of inquiries or requirements that the customers may pose.
Thank you for your time, Akos. Once again, that's Akos Labadie from Eaton Electronics. If you'd like to learn more about Eaton's AEC-Q grade inductors for automotive LED lighting, click the links in the description or visit Mauser.com. And be sure to check back soon for the next episode of Tech Chats.